know is write and balance the chemical equations, because that's going to be very important for later. Then you would convert mass to moles using the molar mass of a given substance. And then you could use mole ratios. We'll get into that later. And then after that, you use the molar mass of the unknown substance to convert the moles just calculated to mass. I know that sounds really hard, but we're going to break that down later so that way it's all easy for you.
It's an analogy of the steps you need to take when it comes to stoichiometry. So, for example, you start either in mass or moles depending on the equation. So from mass to moles, you need to divide the number of grams by the mole, by 1 mole, depending on the atomic number of the element. And you go to mole ratio. We'll get into that later. And then to get from moles to mass, you need to divide the number of moles by the number of grams in the element.
To moles. So whenever you're using stoichiometry, you always want to start with what's given to you. So that would be 50 grams of nitrogen. So then next, you want to use fractions, and you always want to multiply fractions so that way you can divide later. So when you're multiplying those fractions, you always want to have moles on top and whatever this is on the bottom. So that way they're opposites. So that way you can later cancel them out. So here you have grams of nitrogen on top, and then grams of nitrogen on the bottom of the fraction. So that way you can later just cancel it out, and all that you have left is moles. So then next you would need to find the molar mass of nitrogen. So you know that the molar mass of nitrogen normally is 14.007. So then, because there's 2 of them, you would just multiply by 2, and then you would get 28.02 grams of nitrogen, which is pretty simple. So then, now that you have all your numbers figured out, you can finally do crossing out and canceling out. So then you would just cancel out the grams of nitrogen here and the grams of nitrogen here, which would leave you with moles. So then now all you have to do is just divide. So you just take 50 grams of nitrogen and divide it by 28.02 grams of nitrogen. And then all that would give you is moles. So then you would get 1.784 for moles of nitrogen. However, you need to remember to use sig figs. So to do that, you would just know that there are 3 sig figs here because that's the first thing that's given to you. And then you would realize that there are only 3 sig figs here. So all you would have for your end result is 1.78 moles. And that's how you find moles from grams.
Example is, how many grams of calcium carbonate are required to prepare 50 grams of calcium oxide? First, we're going to start with balancing our equation. Our equation is calcium carbonate yields calcium oxide and carbon dioxide. This equation is already balanced for us, so we get to start with the next step. Our next step is using our given of 50 grams calcium oxide. Then we're going to multiply it to our next step with our fraction, which is going to be 1 mole calcium oxide over 56.078 grams calcium oxide. Why we have our grams to grams like this is so once we get through and we start to simplify, we can cross these out. Next, we're going to do our mole ratio, which based off of our chemical equation is already balanced and already has our mole ratio, which is going to be 1 to 1. You're going to continue with the calcium oxide here, but once you get up to the top, it's going to be our calcium carbonate. Then you're going to find the molar mass of the calcium carbonate, which is 100.79 grams. Oh shoot, no. It's okay, just keep filming, I'll cut this later. Then we're going to do our 1 mole calcium carbonate here. So once again, we can simplify that out later. And then we're going to find our molar mass of our calcium carbonate, which is going to be 100.79 grams calcium carbonate. Our next step is to go across, get rid of all our figures so we know what sign we're dealing with, which our sign we're going to be dealing with is our grams. That is the measurement we're going to be using. Next, we're going to get rid of all our ones and multiply across, and then multiply across in the bottom, so then making it to our simplified version, which is going to get us to 50 times 179 divided by 56.078. That's going to equal 89.8659011. Now we have to take care of our sig figs, which are small. When you multiply or divide, you use your smallest amount of sig figs, which is going to come from the 50 grams, which is 3. So that's going to yield to 89.9 based off the tenths place rounding here. And it's going to take 89.9 grams of calcium carbonate to prepare 50 grams of calcium oxide.